It is what it is. I knew I would have a lot to do today. I got a little bit of a late start because my wife is upstate with Bauer because Ziva's in heat. We don't want Bauer to try to be with Ziva. So she brought him upstate. So I got the dogs out this morning, then I had to get them back in. I did this, that, and the other thing. Then as I was coming in, this car pulls right in the middle of the road and just stops. And it was over by West Avenue where you can't get around because they have those medians there. So I'm like, can we move? And then as soon as they move, the railroad crossing goes down. So then I get stuck there. And then I get in here, and then I think I can't find the quiz, and then I find the quiz, and it's just one thing leads to another. So anyway, I am just, not you, I am off my game for whatever reason. So let's hopefully start rounding it out and working it up here. Okay, as far as these values, y, z, x goes, every kid in the room who took the quiz got these right. So I'm going to move past these. Just very quickly, though. God bless, this is the square root of 36 when you do the discriminant, which means it would be plus or minus 6, which means there are two different roots. That's why it has to be y. This one, b squared minus 4ac, works out to be a negative, which means there are no real roots. That's why it has to be z, because it doesn't touch the axis to show real roots. And in x case, it works out to be the square root of 0, which is plus or minus 0, which means the roots are the same. Okay? Because if you add 0, subtract 0, they work out the same way. Now, as far as how to do this one goes, look, the first thing you do is look at this and realize what the factors have to be. What the roots have to be. The roots have to be the opposite of this, because it would be maybe the guy on the left equals 0, that would be negative 4. Maybe the guy on the right equals 0, that would be 2. So I go over here and I touch it, negative 4 and 2. Then I need to find what the axis of symmetry is, and it's in the middle between negative 4 and 2. So this work here adds them up, divides by 2, and I get that x is negative 1, or you could draw it on the paper here. X is negative 1 runs right down the middle. Now, I plug in the negative 1, and I get 3 here and negative 3 there. 3 times negative 3 is negative 9. That means the y coordinate, because y is negative 9 when x is negative 1. So I go down and I touch it, negative 1, negative 9. That's how I made my scale. Notice when I made the scale, I made it on both axes so everybody could see. You could have done a slightly different scale. It doesn't make a difference. Now, I also like to find the y-intercept because I could just plug in a 0 for x. And when I do that, I get 4 times negative 2 is negative 8. So that gives me these two to pair up. And I touch very quickly with the graph. Okay? Any questions? All right. Last night's homework. Here are your factorings. This is an excellent set of exercises with factoring. And the reason they look like this every night is this is every type of factoring that can be thrown at you. So if you can get all of these questions correct, then that means that any type of factoring that they can ask you to do on your Regents exam, you're capable of doing. If there's any one of these that you can't get correct, then that means there's a type of factoring you need to improve at. Yes? I'm sorry? D, again, look for a common factor. They share a 3x squared in common. Right? We always do that first. I pull out the 3x squared and I have x squared minus 4y squared left. And you need to be able to recognize that it's the difference because of the minus sign, of two perfect squares, because I could square root both of those. So that the square root of x squared is x and x, and the square root of 4y squared is 2y and 2y. So I get x plus 2y, x minus 2y, and also the 3x squared I started with. Okay? I wish that I could give you some kind of mantra to shout from the mountaintop, but the truth is it's just a matter of recognizing the common factor and then recognizing the difference of two perfect squares. And you just have to keep doing them until you see it. And once you do, it's in good shape. Anything else? Okay, solve for each. I looked at the first one and I kind of knew right away that I couldn't factor it. So if I can't factor it, I have two choices. I have completing the square and I have quadratic formula. Here I went to quadratic formula. It comes up to the square root of a negative. I do not expect that to possibly happen on your Regents exam, but I don't put anything past New York State anymore. So I do one every now and then just so that you're aware that it could happen. Letter B, very important. I would really love to see you not divide both sides by 4 and then square root both sides, even though it is a little quicker, because my experience is when that happens, kids will leave out the -5. So instead, I like to be a little more methodical about it. And Janelle, this is a lot like that question 1D over here, where you factor out the 4, then you recognize the difference of 2 perfect squares. Maybe it's the guy on the left, the middle, or the right, and I come up with -5 and 5. Do not reject the -5. This does not represent time or length or anything like that. Okay? Questions? All right, now we go to the second sheet. And on the second sheet, I didn't do all of them, but I did one completing the square. I didn't do both. I'm just a little rushed for time. I chose to do this one because it got into decimals, but you don't change anything from the way you do it with whole numbers. Up until now, we've kind of been working whole numbers every day. All right, any questions on the completing the square one? Okay. And then there's the quadratic formula. These quadratics that we're working on, these x squared thingamajiggies, if you can factor, solve by factoring, solve by completing the square, and solve with the quadratic formula. If you can do those 4 things, you're in fantastic shape for your Regents exam, because this is one of the most difficult topics on the Regents exam. And if you can get points on this kind of stuff, there is no way on God's green earth you will fail. All right. Any questions further? All right, let's go to, it's funny, scan 1, scan 2, scan 4. Let's see if we got a scan 3 here. No? Scan 3. This is more of that nature of the roots type of stuff. Okay, the first one works out after I do b squared minus 4ac, it works out to 0. Therefore, the roots are rational, and they're equal, because one would be plus 0, one would be minus 0. Yes?
There was only pictures to match them.
I know, so I just wrote what they were underneath. Next one, b squared minus 4ac works out to be square root of -31, therefore it's imaginary. And the last one works out to be the square root of 49, which is also rational, because the square root of 49 is 7. And I wrote equal. I should have written unequal. That's my daily stupid mistake. I'm very good at those. Okay, any questions on that? I think we're starting to get a little better. Okay, scan 4 now. And this is kind of what we worked on just a minute ago on the quiz. The factors are x minus 5, x plus 3, so that means the roots are the reverse, which is 5 and -3. I find the middle, which is x is equal to 1. You can also look at it on the graph here. I plug in a 1, and I get -4 times +4 is -16, so that tells me the turning point of the vertex is 1, -16. I always like to find out what the y-intercept is. I plug in the 0, and I get -5 times 3 is -15, so I put it right there. And that has to match up with this one. And then I make my nice little U-shaped parabola. One question we talked about yesterday is over what interval is it increasing? It's increasing from 1 to infinity. There's my interval notation. And it's decreasing from -infinity all the way to when x is equal to 1. Any questions? All right. I do believe there's another scan 5. Oh, that was the quiz. All right. And today's lesson sheet. All right, so today is all about vertex form of a parabola. And we will talk about it, go through it, and so on and so forth. Now, this relates very much to last year when you learned about reflections, dilations, rotations, and translations. Do you remember all of that kind of stuff, or remember a little bit about it? Okay, so this is going to be very closely related to that material. As I didn't think that material is hard. I don't think it's difficult. In fact, in my regular Math 8 class, right now we're doing reflections. We did reflections for the first day yesterday, and they had a really easy time with it. So I tend to think this class would have had a pretty easy time with it last year, and that you'll find what we're about to cover this year to be not difficult. So, without any further ado, let's get rocking on this and see what we can come up with here. What we're talking about is another way to write a equation of a parabola. Now, so far, everything we've written is y equals ax squared plus bx plus c, and we graph it that way. But there is another way to graph a parabola, and that's what we're gonna learn now. Petit and Rui each threw a baseball into the air. So this is a graph, I would imagine since, this is, the vertical height of Petit's baseball is represented by the graph P of t below, which is really strange because it's not below, it's above. P represents the vertical height of the baseball from the ground, and T represents the time in seconds. I'm guessing that this table is this graph. I really can't read it well enough. My vision doesn't see.
No, it's not, because the highest on the graph is.
Oh yeah, it's 102 and this is like 96. So then the next option, of course I got this from the state, you can tell by the font, right? Then this is gonna be R of t, and this must be mislabeled. This has to be P of t. All right, because however you say RYU, and this is petita or whatever. So those are the graphs. Anyway, what baseball reached the highest height? Well, this height is 98 right here, and in that we're talking about, and let's just, let's be clear about this. We're gonna call this P, hey! P of t, and there's my maximum height right there, and that looks like it's the point 1 comma, I'm thinking that's 96, I think.
I don't even know, it looks like a little.
Yeah, I think it's going up by 4s.
No.
It's going up by 8s?
It's going up by 6.
It says 14.
No.
Yeah, I think it's going up by 8s.
I'm gonna go with,
8s, it's going up by 8s.
is it by 8s? Okay, then it's at 92. So then it's at 1 comma 92, and this maximum is right here, which is at 1 comma 102. So clearly, Rui or whatever throws, well, you know what? A friend of mine has the name Rui, and that's how you spell it, R-U-Y. And this is R-Y-U. Given the incompetence of New York State Education Department, and yes, this is on video and I hope they hear it, I could see them having misspelled it. Right, R-Y-U? Hey, listen, you know, they just made this lady, Nancy Devos, the head of education, and she sent this thing around where she misspelled a bunch of words and had terrible grammar. And I'm going,
She has
you
no
can't make this
education
stuff up.
background. It's so
I don't
bad.
want to, listen, we don't have the time to get into it. If we did, I would. But, and I don't think she's some kind of an evil character, but can you please, at least if you're gonna be the Department of Education's head person, can you please use proper grammar? Just possibly? Okay,
So sad.
whose baseball reached the highest? We just said that it's gonna be Rui, because I wanna remind myself that this is Rui here, and we're gonna spell it the way I know how to spell Rui. Next, whose ball reached the ground fastest? Now, it reaches the ground fastest when the height is 0. So this is 3.52, and this is gonna be 1, 2, 3. Clearly, can you all see that this is 1, 2, 3, this is 4?
No.
So can everybody, well, no, it's pretty obvious, that's 0.5, and then that one was a whole number. Then 1.5 and a whole number. So can you all see that this red is crossing to the left of the middle point, which is 3.5?
Yeah.
And if it's to the left side, it's less than 3.5. So this one, Petit's, has to hit the ground faster. All right, what does C say? Because I can't move the screen.
I don't know what his name is.
Whatever.
Petite claims that his ball reached,
Petite.
his ball reached its maximum faster than Rui's. Is his claim correct or incorrect? Explain your answer.
No, they
It's a
both
computer.
reach maximum at 1 second.
It's not even close.
So it's not faster, it's equal, okay?
Guy?
All right, what's next?
I'm so
Oh,
AJ, quick.
find P0 and R0 values and explain what it means in the problem. What conclusion can you make based on these values? Did they throw the ball at the same place? Explain your answer.
Okay, here's the deal. R of 0, Ruiz of 0 is 86. Now, that means the function gives you the height of the ball at any point in time. So it means at 0 seconds, the instant before he threw the ball, it was 86 feet above the ground, because he hasn't thrown it yet. So that means he's standing at the 86-foot mark, or the ball's being released from the 86-foot mark. Either that or he's really tall. Now, this guy over here, if this is truly 8s, that's 92, 84, and then that would be whatever,
86.
80, whatever it is. This is the height right here, okay? I can't even begin to read it, so whatever it is. All right, what's the next question?
Rui claims
Rui
that he can
claims
throw
that
a
he
ball
can throw
higher
higher
than what Peter,
Petite.
let's call him Peter. Is his claim correct or incorrect? Explain it.
Rui does throw higher. Oh, actually, no. Rui has thrown the ball 16 feet high, from 86 to 102. Okay? If this is going up by 8s, well, this is also thrown at 16 feet high. 8 and another 8 is 16. So that means they both throw the ball 16 feet high. Okay? The height, we all understand that Peter or Pettit or whoever started higher than Rui did. The question is, how high did the ball go from 0? And in this case, in both cases, the ball went up a total of 16 feet. From 86 to 102 is 16 feet. And if these are going up by 8s, which we're guessing at, that's 8, 16, and that brings us to the mark. So they've both gone up 16 feet. Next question.
There's no.
That's it, okay, good. Now we get to the vertex form of
Boy,
what we have going on. Okay, so what I would like you guys to do on your calculator very quickly is, and we do need to do this very quickly. Everybody on your calculator, quickly graph your calculator, graph these three things. F1, for y1, do y equals x squared. For y2, do y equals x minus 2 squared in parentheses. Actually, you know what? Let me change it slightly. Ready? Do these. Y equals x squared. Y equals x squared minus 2. And y equals x squared plus 2. Everybody do those three.
Shouldn't it be x squared minus 4?
No, no, I just want you to graph that. Just graph it, see what happens. You're gonna notice something about the graphs.
Oh, they're so cool.
What do you notice?
They're like all
They're all near
they're
each
like,
other.
Yeah, in other words, y equals x squared, the first graph is right in the middle, right?
yeah.
And it's there, and then the y equals x squared minus 2 is the same exact graph. This is y equals x squared, it's the same graph, it just goes down a little. Okay? In fact, it goes down 2. You think that minus 2 has anything to do with that? And then the next one says y equals x squared plus 2, and what does that do? It goes up 2. Now, notice that word up and down, or the words up and down. So that number at the end, listen very carefully, please don't fade away. That number at the end is up and down. What word do we use to describe up and down? Starts with a V? Everybody? Vertical. So that number at the end is vertical change, and we'll talk about it later, vertical shift. Now do these three on the calculator.
Do we clear the other?
Yes, clear. Well, the first one stays the same.
oh great.
How do we get like all three lines on the same graph?
That's it, perfect. Then you go to graph.
Well, I did that. That was the only, that, it was only one line.
Weird.
Wait, what happened?
Oh, you know, maybe because you don't have a Y2 there?
No, I do have a white too, look.
Yeah, let's do this, ready? Second, mem, 7, 1, 2.
That's so cool.
Now do them again and I think it'll work. I just reset your calculator. Something was
My
wrong
graph is
somewhere.
weird, cause like it's
Okay.
not in the middle.
Oh, that, you can just do Zoom 6, it puts it in the middle. Now, this time, your graph should look like this. Here's y equals x squared in the middle, and then the first one goes over here, and the second one goes over here. Everybody got that?
Yeah.
Okay. Now, this is not vertical, this is what?
Oh,
Horizontal, because it's sliding left and right. So here's what we come down to. Anything inside the parentheses is what we call horizontal shift. And everything outside the parentheses is what we call vertical shift. So in other words, everything is y equals x squared. And then I just put in a parenthesis to move it left and right, and I put a number at the end to move it up and down. And then I can quickly sketch whatever my parabola works out to be. So you tell me by looking at this, oh, and also if it's in the parentheses, you reverse it, just like with the roots, okay? What would be the vertex in letter A? What would be the vertex?
3.
Well, the 3 would be the y coordinate of the vertex. What would be the x coordinate? Remember, you reverse it in the roots. What would it be, everybody? No, it'd be 5. Because you're going to move 5 to the right. You reverse. Usually negative goes to the left, but in a parenthesis you reverse it. So you go 5 to the right, up 3. The vertex would be 5, 3. On letter B, do you see any horizontal shift at all? No, it just says x squared, so that's 0. And what would the vertical shift be? Negative 2.5. Very quickly on your calculator, everybody type in y equals x squared minus 2.5 and see if the vertex looks like 0, negative 2.5.
We don't have to change the y. Yeah.
No, the vertical shift stays the same. It's only in a parenthesis that it ever gets reversed. Okay? Now, I'm sure that your graph looks fine. Next one, what would the vertex be?
4.
It's not 4, be careful, it's in a parenthesis. Negative 4. In a parenthesis, you reverse it. Negative 4, and then what's the vertical shift?
0.
0. Everybody quickly on your calculator graph that one. And you should see your parabola with the vertex at negative 4, 0. Everybody see that? Okay. Now let's go to writing the equation. I'll write the first one. Ready? Y. Y equals x minus 1.9 squared minus 4. Right? I just reversed it. That says positive 1.9. Hold it. What's the next one? Y equals what?
0 x squared
X squared or x minus 0 squared. Either one. What?
minus 100.
Plus 100. The vertical shift stays the same. The horizontal shift gets reversed. Okay? We have one more day of this tomorrow.
No, that's tomorrow.
And we also have to talk about the number in front tomorrow. So we're about halfway through understanding how to do the vertex form. Hasta la vista, vaya con Dios, toodaloo, ta-ta. I'll leave it there, Chase. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Corushinus. Kadafis.